Let me go to YouTube.
So, Brian, if your video cuts out.
Now it seemed like it buffered all of a sudden, and then we got like a real quick movement of your mouth, of your lips on the cam.
If my video drops out, is my screen going to still be shared, or is that not going to work either?
No,
that might be something separate.
No, I think that's something separate.
Okay, so if you don't see me, that's might not the end of the world.
And just so you know, the camera one is running off of a Wi-Fi, and that's why it's a little sketchier, whereas the other ones are direct. So.
All right, let's see if it's running. Ooh, it is. Well, good evening, and welcome to Kopernik's FNL, Friday Night Live Stream. I'm Drew Desker, Director of the Kopernik Observatory, and welcome you here this evening for our program on the SKYWARN Storm Spotter program. Want to especially welcome anybody who might be watching for the first time. We are normally we'd be doing this up here at Kopernik on a Friday night. Normally we do Friday night programs where people come up, talk about various topics of not only just astronomy and space, but engineering, various aspects of science. Actually, just last week we had a talk on cicadas brood 10, and we had to talk about the Arecibo dish a couple of months ago. And anyway, back when the pandemic made us close down, we ended up pivoting and doing this all on a YouTube live stream. And it's actually been pretty well received, and we really enjoy doing it. And we hope actually to be able to get people to come back up here again, hopefully in July, I'm thinking. And we will probably still continue to live stream because it's so well received. And again, people from literally around the country will be watching at times. This live stream is, and our Friday night programs are sponsored by Broom Pediatrics. So we thank Broom Peds for helping us make this happen. And also want to make sure you're aware that if you've got any children or grandchildren that are looking for a summer activity, we are going to be offering our summer camps in person up here at Kopernik. We're going to be limiting the number of students per class to keep the population down, but we're really looking forward to having kids come back up here. And again, we're looking forward to being able to offer our Friday night programs up here. If you're in a position, if you like what you see tonight, and if you're in a position to help us out, if you look down in the description below on YouTube, there's an opportunity to support us monetarily. So this is free, but if you're in a position to help us out, that'd be great. Well, tonight's program on the SKYWARN Storm Spotter program is actually something we've had people from the National Weather Service in Binghamton up here talking about inclement weather, but we've never had this particular program. I'm really excited to be able to do that. I think especially now it seems like storms have become more and more active, let's put it that way. And having shoveled 40 inches of snow off the domes out here this past winter, I'd like to know more about that. But also, I think it's important that the National Weather Service knows what's going on in the area, and that's really what this program is about. So, very happy to introduce our two speakers, Brian Greenblatt and Mark. And I'm blanking on your last name, Mark. Anyway,
Pellerino.
Thank you.
Yeah.
Anyway, I'm going to stop talking and turn it over to you. And you guys are actually up at the National Weather Service right now, right?
Yes, we are.
Excellent. All right. So,
office.
Take it away.
I'm in the conference room, and Mark is in another office within the office. So.
Great.
All right. So let me share my screen here.
And actually, while you're doing that, I'm going to say that if you have any questions for Mark or Brian, put them in the chat, and at the end of the presentation, I will pass those along to them for their answer. All right. Right now, we got your calendar.
Hold on 1 second.
Oh, you left the meeting.
No, come back. Come on back.
There we go.
There we go.
I had that Zoom banner blocking the tab. So.
Yeah.
All right. Thank you very much, and thanks. And it looks like my video just failed, but I think my audio is still going. So.
Yes, it is. You're good.
Yeah, we hear you, buddy.
So welcome to the basic SKYWARN training. My name is Brian, and we also introduced you to Mark. So both of us will be co-presenting this, and we will also give you a little bit of a mini tour of the office. And Mark will be doing that actually shortly. Actually,
yeah.
Right now. So we'll get started on that right now. Is it Mark, you want to take over?
Yeah, we'll get into the outline of the actual SKYWARN in just a moment, but while we still have some daylight, I'm going to show you around here real quick. So I was just happened to be in an office here, but the rest of the operations area is just outside here.
Hey, Brian, could you unshare? This way we can actually be able to see it a little better.
Oh, yeah, okay.
And
actually, okay.
I'm going to make you the active speaker. There you go.
Okay.
Now we're good.
All right, you seeing everything here?
Yep.
Okay. All right, so we're going to do a quick walk around here. I just happen to be in one of our offices here, but this right here that you're seeing is the operations area of the National Weather Service here in Binghamton. I'll revisit this in just a moment, but let me take you outside here real quick, too. And, you know, as with any office, there's this standard hallways and bathrooms and things like that. But and then here's our entryway. So we are located. I'm hoping this this Wi-Fi connection holds pretty well here. But yeah, so we are located right next to the Binghamton Airport, and there's the old water tower there that you see for the Binghamton Airport. Also, satellite dish, which brings in a lot of our data. And then this is the entrance of our building here at the National Weather Service. Also, we have some equipment sitting out here, including this white painted shelter for temperature sensing and stuff. It's painted white so it does not absorb heat. And then you see here a rain gauge, also a wind break so that when the snow comes in, it doesn't blow right across the gauge. It actually is able to collect some stuff. So this is just what it looks like here on the outside. Big old building here. And now I'm going to take you back in here. There's our sign, National Weather Service. And so, as you come into our building, this is if the snow gets really bad. All right. And there we go. Here's our entryway with the signage and also some pictures from our beautiful area here we serve central New York and also northeast Pennsylvania. We have you know, many cool areas to go hiking and camping and everything else. And this is where our administrative assistant sits. We also have what's called the Weather Ready Nation Ambassador Program. That's what you're seeing there with all our different partners throughout the area. Lots of counties, some emergency managers, amateur radio, American Red Cross, and various media partners as well. They help us get out the word whenever we have active weather and also awareness weeks of winter, summer, storms, all that stuff. Okay, so back into the operations area now. You can see that there's several workstations with many monitors for monitoring the weather. And they're around the clock. We have at least 2 of us here, and often more than that. Here we have Brian, another Brian. He's the lead forecaster for tonight. Hello. And then over here we got Jake. Jake's our newest forecaster here, but he was an aviation meteorologist for many years and has since moved up here to the fun weather, 4 seasons weather that we have. Okay, and then this right here is just what a workstation looks like. Brian, if you could give me a heads up, because I can't see what I'm pointing at. Is that, you able to see the screens here pretty well?
Yep, you're good.
Yep.
Okay. All right, so on the left here is a screen where we actually edit our forecasts. We do this in collaboration with several surrounding offices. So it's basically a database of all of our forecasts, whether it's temperature, humidity, chance of rain, type of weather, and in the case of if we ever get, you know, severe thunderstorm watches, winter storm watches and warnings and stuff, we do that all through this little editor here. On the right side here is a display of the current weather. And so you can see here we have areas of clouds moving across the Great Lakes to northeast and some temperatures and things like that. And then we also are able to really digest the computer models of what's going to be happening in the future. And we look at different levels of the atmosphere and precipitation and clouds and wind and everything else. And then, of course, we have other computers as well. This right here, for example, is a thunderstorm in Colorado. Let's see. Yeah, there we go. And we're able to really dissect these storms and get a 3-dimensional look at everything that's going on. You can see the atmosphere in a vertical profile, how much instability there is. We also put together graphics all the time for display on social media and all that stuff. For example, this is the one we put out early this morning for the heat that we're experiencing for today. So, yeah, like I said, this is, you know, the operations area. In a severe weather day, you would see all these stations taken up with with people doing, men and women doing the work of the National Weather Service, taking in not just monitoring the radar displays and all that, but also taking in phone calls from storm spotters and all that. So, and then here you see behind Jake, we actually have a tropical depression wannabe trying to get organized there off the coast of Texas, and other displays for all the data that's coming in, radar display for its status, and what have you. So that's just a quick tour of what it looks like here, and at this point we're going to turn it back over to Brian, and he'll get the SKYWARN presentation started.
All right, thanks, Mark. Hope you all enjoyed that brief tour of our office. Let me share my screen again. Share. Okay, so you should all see the outline again.
Yep.
So this is the basic SKYWARN presentation again. So we're going to go over what the National Weather Service is and what a weather spotter is. That's going to be the beginning part of this. And then we're going to talk a little bit about thunderstorms and a little bit more about ingredients about thunderstorms and clouds. Toward the end of the presentation, we're going to talk about how and what to report to us, and also how we get the word out to all of you, how we get the forecast and our warnings out. And at the end, there'll be a little bit of a wrap-up and an opportunity for a question and answer session. Okay, so the National Weather Service. Well, our office, we are one of 122 offices spread across the whole country. So I know we have probably some people on here from different areas of the country. This particular office forecasts for Northeast Pennsylvania, 7 counties in Northeast Pennsylvania and 17 counties in Central New York. So we serve about 2.5 million citizens between Central New York and Northeast Pennsylvania. And like I said, spread across the whole country, we have 122 field offices. We also have a bunch of different other centers that the Weather Service has. We have river forecast centers. We have regional headquarters. And we also have National Weather Service headquarters in Maryland. So here is, and you kind of just saw this from the tour, but this is a image of our office. We are located at a 1,600-foot elevation, so we are just north of Binghamton, actually. We are up on the hill, as we like to call it. And as I mentioned, we're one of 122 offices spread across the country. So regardless of where you are in the country, there is a Weather Service office that forecasts and issues warnings for your particular area. The National Weather Service mission is to provide weather, water, and climate forecasts and warnings for the protection of life and property and the enhancement of the national economy. The key here is highlighted in red, the protection of life and property. Our main goal is to issue warnings and forecasts and to protect all of you and all the citizens of Northeast Pennsylvania. Well, for us, Northeast Pennsylvania, Central New York, and all around the looks like my video failed. I'll just keep on talking here. So here we have different events that have happened over the past several years. Bottom left is an image of a shopping center in 2018 that was destroyed by an EF2 tornado in Wilkes-Barre, Pennsylvania. Top left, this was actually taken by myself. I was here at the office during that big 40-inch snowstorm. I was on the midnight shift, and day shift actually could not make it into the office that day. So we, the midnight shifters, we ended up pulling a double shift, and we were here until late in the afternoon that day. So that was a pretty long day. So let's go to the next slide here. So what is a SKYWARN program? So the SKYWARN program, and most, if not all, Weather Service offices across the whole country have a SKYWARN program. And basically, the goal of the SKYWARN program is to provide the National Weather Service with ground truth reports of significant weather. I keep getting a banner that comes up about my video, so excuse me. Let me get this banner out of the way. I'm sorry. All right, here we go. Oops. All right, so our main program is to get ground truth reports. We have technology, we have radar, satellite, and many other methods to know what's going on, but the best source is obviously what's going on at the ground, and that is why we have trained spotters, and that is the purpose of the SKYWARN program. Okay, so how do the National Weather Service trained spotters help the Weather Service? Again, I just kind of mentioned this before. The key here is the trained eye of the storm spotter is still our greatest asset. We may have all this technology at our disposal, but the best source are the people at the ground giving us reports. And this will be emphasized multiple times throughout this presentation. Whenever you do send reports to us, please only do so if it is safe to do so. You do not want to put yourself in harm's way just to send us a report. So why are we so concerned about thunderstorms? Well, thunderstorms do have multiple hazards, mainly lightning, high winds, hail, tornadoes, and or flooding. So I'll go through each of these hazards in a little bit more detail here. So lightning is a bolt of electric discharge between the cloud and ground, or within a cloud. The most dangerous type of lightning is cloud to ground. That is when it directly reaches the ground. And what's important here is that lightning can strike as far as 10 to 15 miles away from where it is actually raining. So just because it is not raining where you are located does not mean you cannot be struck by lightning. So whenever, one of the phrases, a few buzz phrases, is when thunder roars, go indoors. So basically, whenever you hear thunder, you want to seek shelter and stay out of harm's way. And I hope you all hear this video.
They say lightning never strikes the same place twice, but what happens if it strikes once? Hey guys, Leanne at the National Weather Service. There are a lot of myths out there about lightning, and did you know it can strike you in ways you never thought possible? You could get struck walking your dog, or even just standing on your porch. The fact is, lightning is more dangerous than you think, and just to let you know, lightning can strike the same place twice. Lightning strikes the United States about 25 million times a year, and of the hundreds that are severely injured, about 49 people die. Interestingly enough, lightning and tornadoes are similarly as dangerous and as deadly. A common misconception is that all lightning strikes are fatal. Good news is, that's not true. Researchers in the lightning safety community say that 90% of people struck by lightning survive. Of those that do survive, some are left with lifelong neurological problems. Also, a study published in the Journal of Neurologic Clinics state that the primary cause of lightning death is cardiac arrest. Basically, your heart and your breathing stops and you lose consciousness. Now let's move on to something even more striking. Lightning is a sudden discharge of electricity from the cloud, the ground, and the air. It can even occur in other instances like volcanic eruptions, but for our sake, we'll just stick to thunderstorms. True or false? Lightning only occurs underneath a thunderstorm. False. Ever heard of a bolt from the blue? Lightning can actually travel 10 miles or more horizontally from a storm. In 2001, two guys were playing football on a beach in New Jersey under sunny skies, when a lightning bolt from a thunderstorm offshore struck and killed one of them. Okay. You're probably thinking right now, I get it, lightning's dangerous, but how can I protect myself and my family from it? Alright, let's go over a few steps. If you are expected to be outdoors, plan ahead. Check the latest forecast at weather.gov and click on the location that you're interested in going to. If there's a better weather day, that's a better option. When out and about, have a game plan on what action you'll take if lightning threatens. Have a shelter in mind of where you will want to go to. It needs to be a building with at least 4 walls, a roof, wiring, like a home, a school, a church, or an office building. But stay away from pipes, metal objects, showers, sinks, bathtubs, and electrical equipment such as stoves, radios, corded telephones, and computers. Another shelter would be any fully enclosed metal-top vehicle. But don't even think about that golf cart. You wouldn't stand a chance. Let's say you're in the middle of nowhere and you don't have any shelter. What do you do then? Well, my fellow Weather Service colleague and lightning specialist, John Jensenius, suggests, if you're in a group, spread out. Avoid open areas. Try not to be the tallest object in the area, and do not be near tall or isolated trees. However, keep in mind there are no safe places outside in a thunderstorm. Watch for clues of an approaching or developing thunderstorm. If you hear thunder, the storm is already close enough that lightning could strike you, and you need to get to shelter immediately. Once in a safe shelter, stay there for 30 minutes after the last rumble of thunder. Puffy white clouds that don't change much shouldn't cause any worries. If these clouds start to grow upwards towards space, you should be prepared to take shelter from lightning. This is a thunderstorm cloud and you should seek shelter immediately. Now here are some common outdoor activities that people participate in, and you tell me if you would be safe from lightning. A day at the golf course. Watching a thunderstorm from your porch. Boating. Mowing your lawn. Whoa, that was enlightening. Now here are some real-life examples of what people were doing when they got struck by lightning in recent years. Some of these common activities might surprise you. Sheltering under trees, fishing, on a boat, riding a motorcycle, mountain climbing, hiking, football practice, hauling hay in a tractor, kids on bikes, standing in the doorway, taking out the garbage, mowing the lawn, inside talking on a landline phone, walking dog, standing next to a window, playing organ in a church, and doing something as simple as getting a book from their vehicle. As we like to say at the National Weather Service, when thunder roars, go indoors. For more information, go to lightningsafety.noaa.gov. Yeah, I gotta go.
Okay, so hope you all enjoyed that video. Hopefully you all heard that video. Sometimes there are technical issues.
No, that sounded great. Good,
okay, good
audio.
Perfect. I don't know if you all see this banner that keeps popping up, so hopefully it's not showing on your screen, but I'm having technical issues in my video, so at least you can still hear me. So again, when thunder roars, go indoors. There's no safe place when there's a thunderstorm around. And this kind of just repeats what a lot of the video says. So I'm not going to go through each one of these, but again, you want to stay away from all these particular examples. Okay, so moving on to more about thunderstorms. So one of the commonly misunderstood, because it's not a tornado, many people think that, oh, it's no big deal. In fact, downburst or straight line wind damage, because it's a little bit, it can be just as strong, or if not stronger. So this graphic at the bottom left kind of shows it pretty well. So you have basically descending air known as a downdraft, and then it basically spreads out from this image to the left and to the right. And you have what you call a downburst, and there's two types of downbursts. There's a macroburst and a microburst. The only difference is the size, the width of the damage. So macroburst is greater than 2.5 miles. Microburst is less than 2.5 miles. So at the bottom right here, we have just a picture of some macroburst damage. I actually went on the storm survey. This was only a month or two after I started working here. But the damage, we actually had an EF0 tornado within that damage, but the most impressive damage was not the tornado damage. It was actually the macroburst damage. Here's a video. I don't think this one has any sound. It's just a time-lapse loop. You can kind of see the wind kind of spreading out from the storm here. So here's a little bit slow motion. It's pretty neat phenomenon, but of course it's very, very dangerous if you're in its way. Okay, so what does a downburst look like? On this image here, we have reflectivity, which basically indicates how heavy the rain is falling. And we have velocity, which the radar detects if there are objects or the wind is moving to or away from the radar. So in red is where motion is away from the radar. Meanwhile, in green, the motion is towards the radar. So on this image here, you can see this red blob over here. That is a wind that's going away from the radar. Meanwhile, the green is toward the radar. So you kind of see it fanning out from two different directions. So that is a little bit what a downburst signature looks like on radar. And again, downburst damage The main difference in direction of the damage when you so with a downburst, you have the damage kind of fanning out left and right. Meanwhile, you have the damage kind of converging towards each other. So it does look a little bit different when we're out in the field, farm surveys and all that.
Hey, Brian, if you can hear me, this is Mark. Can you hear me?
Yes.
Your audio is starting to snag up quite considerably. I'm wondering if maybe, Drew, could you transfer the control over to me, and we will we'll present from this computer, which is probably more stable.
Sure.
Okay, so you want me to switch to where you were?
Yeah. So if you just unshare, Brian, and then Mark, you should still have sharing authority.
Okay. All right, let's give it a try here.
I'll hop in the same room that Mark is going in.
All right, hang tight.
There we go. I see a blank screen with the windows. There we go.
Okay, are you seeing a...
Yep. Make that full screen and get to the slide that you want. Yeah.
All right, I'm going to bring this back up here.
Thanks for calling that out. I was literally just about to suggest something similar.
Having two different displays going here. Okay. All right, we're gonna have Brian take over here. Hang tight.
You have the presentation up?
Yeah.
Okay, I see. All right, sorry about that. Of course, there's always possibility of some technical difficulties. Whenever we do it this way, so.
All right, here we go. And Brian, you are...
We're good? Okay, there's my camera, and there's the screen. So
yeah,
the screen is to my right, so excuse me if you see the side of my head. All right, so a shelf cloud. So that is, this is an approaching thunderstorm. This is approaching, this particular example is the Melbourne, Florida office. But that is the indicator of an approaching severe thunderstorm. So here, let's see here. Here's a loop. I don't think this one has audio either, so this is just a loop of an approaching shelf cloud, an approaching severe thunderstorm.
It really has sort of almost an anvil kind of look. It's sort of amazing
Yeah,
how
it's definitely it's a pretty ominous, pretty ominous sign. Definitely when you see this, and this. I sure hope this was on a tripod and there was nobody nearby, because now I guess they adjusted it. So there is somebody there, and there's a lot of lightning. So you do not want to be this person taking a video. Skip ahead a little bit. Okay. So another hazard from thunderstorms is hail. And a lot of people confuse hail and sleet. Sleet is a form of winter precipitation where you have snowflakes that melt and then refreeze and hit the ground as ice pellets. While the end result of hail is very, very similar, it's kind of frozen ice pellets, the formation of it is very, very different. And these are formed in thunderstorms where you have an updraft, you have rising air, and you have a lot of circulation in that. And basically these water droplets stick to each other and then they freeze. And eventually they become too large and too dense, and they fall to the earth along with the downdraft. And when they fall to the earth, they fall down as ice pellets, and that is what's known as hail. So the stronger the updraft, the larger the hail will be. And this next graphic shows different hail sizes. So hail can range in sizes. It can be very, very small, even smaller than this this graphic here. It can be pea-sized, or it can be as large as CD or DVD sized. We generally don't see hail that large in this part of the country. That's generally more in the center part of the country, in what we call Tornado Alley. But hail can range a bunch of different sizes. And anything 1 inch diameter or larger is considered severe criteria hail. And that Mark will go over that in a little bit more detail. So here is a image of just 3 inch diameter hail in Otselic, New York from 2011. This is just an example of quite large hail. And this is going to do quite a bit of damage if you are under this type of storm. And this is a video. It's a pretty small hail, but this was at the office many years ago, I think before I got here. Okay. So what does hail look like on radar? Well, this is a cross-section of a particular thunderstorm, and basically where this arrow is pointing over here, this is the updraft. This is where you have the rising air. And hail is a large object, so it's going to be a lot more of a reflective object, and on reflectivity it's going to be more of these brighter colors where you have these pinks, purples, and sometimes white. So this over here is your hail core. A few fundamental definitions here. There's a big difference between a tornado and a funnel cloud. A funnel cloud is basically a tornado that has not yet reached the ground. So it is a rotating funnel that extends from the thunderstorm base. Again, the key here is it does not reach the ground. It shows rapid rotation. But meanwhile, a tornado is a funnel cloud that has reached the ground. And at that point, if there's anything nearby, it will cause quite a bit of damage. So here we have another particular example of a radar image in terms of velocity. And this is what kind of like a tornado kind of would look like on radar, where we have this couplet here. So we have, again, red is away from the radar and green is towards the radar. So you basically have a kind of a circulation. It's not just straight left and right, but there's actually a little bit of circulation here in circles here. This is kind of what a tornado may look like on radar. This is an example from 2013. And here's a video, and I'm not going to show the whole video. It's about 2 minutes long here. But this is a funnel cloud, and you can kind of see how quickly it will develop into a tornado. So this video is 2.5 minutes long, or a little bit over 2.5 minutes. And skipping through here, you can kind of see it's starting to lower. It's still a funnel cloud at this point. And around this point, it has reached the ground. So at this point, this funnel cloud is now a tornado. And then skipping ahead even more, at this point, it's a rather well-defined, strong tornado. Now, I skipped ahead in this video, but keep in mind, this is 2.5 minutes long. We went from this, which is just a funnel cloud, to this pretty well-developed tornado in about 2.5 minutes. So these tornadoes can develop very, very quickly. And as I mentioned earlier, there's a difference in what the damage looks like, especially with trees, between straight line wind damage and tornado. And remember I mentioned how it converges to a single point with tornado damage. So here you can see trees that are pointed towards the right and then towards the left, and they're kind of converging towards this middle area over here. This is likely where the tornado tracked. What's also really neat about this particular image here, you can kind of see in this field over here kind of a scar. And this is actually the tornado kind of kind of picking up the grass and everything like that. So sometimes you can even see it in grass in terms of looking at a tornado or tornado damage. And this is just an image here. It's a little bit kind of hard to tell, but these trees are kind of pointing towards each other, converging to a single point. So tornadoes are rated on the enhanced Fujita scale. Anywhere from between an EF0 and an EF5. So EF0 is the weakest tornado. It's generally between 65 and 85 miles per hour. Meanwhile, EF5 would be the strongest tornado, and that's 200 to 234 or really above miles per hour. Generally, in this part of the country, we do not see tornadoes at the higher end of the scale. Generally, they're EF 0s, 1s, sometimes 2s, and sometimes a 3. But generally, they're on the lower end of the scale in this part of the country. The strongest tornadoes are generally found more in the center part of the country or down south. And another hazard from thunderstorms is flooding, and particularly in this part of this part of the country, in this part of the state. So we have quite a bit of a difference in elevation in our forecast area. We have the Catskills to our east, we have the Poconos to our south, we have some higher hills in central New York, we have some higher mountains in Steuben County or far western county. So we have all this terrain, all these rivers, and basically there's nowhere for the water to go except for just kind of flowing away. So a big difference between this and where I grew up. I grew up on Long Island, downstate, where Long Island is relatively flat. It's a sandy soil. Meanwhile, in our area, we have more of a clay type of soil where the water doesn't really absorb into the ground. It kind of just runs off. So we do have a quite extensive of a flood history, both in terms of flash floods and river floods. Just going over a little bit of different warnings and advisories we can issue with floods. So we can do river flood warnings, and that is pretty self-explanatory. That's when we're expecting flooding on the main stem rivers. Meanwhile, on the top here, a flood warning or aerial flood warning. This is a longer duration developing flood that would occur on rivers, lakes, or larger drainage areas. Meanwhile, a flash flood warning is when a rapid rise of water is occurring on streams, creeks, developed areas. And these are, all flooding is dangerous, but flash flooding is particularly dangerous because of how quickly it occurs. You'll go from no water on the street to water rushing through the street and washing out bridges and homes and everything like that, and roads, as you can see in this image right here, where they kind of just ate away at the road. So the big difference between flash flooding and an aerial flood is just that the difference is less than 6 hours for flash, and generally longer than 6 hours for aerial floods. And again, we do have quite an extensive flood history in our region. Most recently in 2018, that was the first year I was working here at the National Weather Service, we had quite a bit of flooding in northeast Pennsylvania, particularly in Bradford County. We also had quite a bit of flooding in the Finger Lakes region. I know August of that year was a pretty active month. But then we've also had pretty extensive floods. We had a flash flooding from Tropical Storm Lee back in 2011. That is a big one. Hurricane Agnes in the 70s. That was also another big flood, and many others. So we have a pretty extensive flood history. And that's basically we have all forms of severe weather, but this is our most common form of severe weather in our particular area. And with this, I'm going to turn it over to Mark. I will be finishing off the presentation at the end. So I guess I'll slide out of the way. All right. Howdy. This is Mark here again, Mark Pellerito. I've been here it's my 10th year at the National Weather Service in Binghamton, and I've about 16 years in the Weather Service itself, taking me from Montana to West Virginia, and now here in Northeast PA, Central New York. So let's go over what a severe thunderstorm is, because thunderstorm, right? All thunderstorms have lightning and stuff, but what actually discriminates between a regular old thunderstorm and one that is considered severe? Based on all sorts of studies, engineering, and all that stuff, once you hit about 58 miles per hour, it's like, wait, why 58? Why so? That's such a cute little number. 50 knots, that's what it comes down to. It's 50 knots, which happens to be 58 miles per hour. That's when you start getting more significant damage, not just leaves and twigs, but you're talking about branches the size of at least your forearm, and maybe even trees themselves, and also structural damage. Same thing with hail. Yes, small hail can be bad, especially to crops. If you get a whole lot of pea-sized hail, that'll take out crops, so it's bad, right? But once you get 1-inch diameter hail, which is quarter size or larger, that's when you're talking about, okay, some real structural damage starting to occur, and also a storm that
the strength of a storm that is required to produce hail like that often is associated with other forms of severe weather as well. And of course, any tornado is severe. But keep in mind, any thunderstorm by definition, if it has thunder, it has lightning, and lightning itself is life-threatening. So keep that in mind. But yeah, what is a severe thunderstorm? It's those elements that we were just talking about there. So what kind of severe weather do we get in our area? This right here that you're looking at is almost 7 decades worth of tornado paths in the region. So what you can see there is like, okay, yeah, we do get tornadoes. It may not be Oklahoma, but we do definitely get our tornadoes. Many of them are on the weak side, F0, F1 type, so that's, roughly 100 miles per hour or less. That's most of our tornadoes. Most of our tornadoes are also either a single point or a very short path, only lasting a few minutes. But now let's narrow this down to the strongest tornadoes. This is F2 or greater, so now you're talking over 100 miles per hour. And yes, we do get those, but not quite as common. Notice the paths are a little bit longer as well. These are the ones you will more likely hear on the news because these are the ones that are more capable of producing a lot of damage and unfortunately deaths and injuries. For example, back in I think it was 2014, where Madison County, we had several deaths there from that F2 tornado. Is it Smithville? I can't remember exactly which town, but yeah, that does happen. Also, more recently, down in Wilkes-Barre, which we'll see examples of in just a moment here, we had that just about 2 or 3 years ago. Okay, so wind, severe thunderstorm wind gusts, yeah, that's a lot more common, as you can see on this. It's all over the place. And this does not even include down tree. Like if you have a down tree, it's like, how strong was that? Don't know for sure. These are actual measured wind gusts that you're looking at here, or at least estimated wind gusts. So very common. And hail too. Hail, when you're getting inch or larger hail, that does happen when you add it up over many decades. Everyone tends to get at least a little bit of hail. Prior to 2010, this map includes penny-size hail, which is no longer designated severe. It's quarter size or larger that's designated severe. Now, if we're talking about severe weather season, this right here is, if you map it all out, especially pay attention to that magenta line. That's when you combine all forms of severe weather together. Notice we are just getting into our peak. Late May is when things start to wake up around here, and that lasts right through July, and then starts to pare down a little bit in August. Yeah, it could still happen. Most months of the year, in fact, all months of the year, there has been at least some severe weather in the area. But there you can see what's more common. Late May, right through July and August before paring back in September. How about time of day? All right, so do we get severe weather at 4 a.m.? Well, it's not common, but it does happen. And in fact, in 2011, there was a major tornado outbreak all over much of the U.S. Many of you may remember, like Tuscaloosa, Birmingham, Joplin, all that was that year. And during the April one, we had some middle of the night tornadoes during then. But our peak times is when you get to about 2, 3 o'clock in the afternoon, right up to 8 or 9 at night. That's when you have the most instability, the most ingredients usually coming together. And so that's when severe weather tends to be more common, tornadoes and all forms of severe weather. Okay, now we're going to go through the ingredients, all right? How do we get a thunderstorm to just appear? You got to have several ingredients. One is instability, which is the fancy word for just, how is it stable or unstable? Is it an unstable situation? Instability. It's how we measure how unstable the air is, how much energy it has. Usually we're talking about cold air versus warm air. Warm air, like when we see in Otsiningo Park in Binghamton, warm air goes up in the hot air balloon, right? It's less dense. It wants to go up. The cold air is heavier, and so it sinks. And when you have a situation where you have warm air heating up the ground, the sun heats the ground heats the air on a hot summer day, just like we've had the last few days. Hot air underneath cooler air, that's an unstable situation. So you can get it from one of two ways. You can have the the ground level being hot or the top level getting colder. Either way, you're creating an unstable situation. So that's instability. Because ultimately, we're talking about an updraft right here, okay? Instability, however, if it's really unstable, then you get a strong updraft. And I'm talking, these wind speeds that you're talking about here, that we're seeing here on the screen, we're talking about wind straight up, all right? 30 to 50 mile an hour updraft, straight up. That's what creates a thunderstorm. And a severe thunderstorm, it's more like 50 to 70 mile per hour. And then supercells, which we'll get into shortly here, you can actually have an updraft straight up more than 100 miles per hour. And this is why airplanes do everything they can to avoid thunderstorms, because that's an extreme amount of turbulence. Also, if you think about large hail, imagine baseball-sized hail. Wow, that's big, right? Well, what that means is quarter-size hail, which is a chunk of ice, was still too light to fall to the ground when you have a strong updraft, like a 100-mile-an-hour updraft. And so eventually it gets so big to where it eventually drops. I mean, these are strong updrafts. That's how you get these overshooting tops on these storms. Now, granted, we have a lot of hills and trees and things in the way to where we don't usually get a view of a storm from this far away like you're seeing in these examples here. But if you could see a severe thunderstorm in the distance, you would see this overshooting top. Usually a thunderstorm will spread out in the anvil shape that you see there because it hits the top of the troposphere. That's where you get, it just spreads out because that's where the atmosphere stabilizes. But if the updraft is going 100 miles per hour straight up, you'll have this overshooting top that you see in these examples here. All right, so yeah, that's ingredient number one. Ingredient number two is you need moisture, right? You can't make you can't make like if you're making something out of Play-Doh, you got to have the actual Play-Doh, and that's what makes up a storm is moisture. All right, and we have no shortage of moisture around here. This is not California. This is not Arizona. We get moisture from the Gulf of Mexico. We get it from the Atlantic seaboard. And we even sometimes get moisture from the Great Lakes, especially in the winter for the Great Lakes. That's how you get lake effect snow. So no shortage of moisture, and that's why flooding is our bread and butter when it comes to severe weather. It's what we get all. Yes, we get all forms of severe weather, but especially flooding. All right, so moisture, we got plenty of moisture. The other thing about moisture is, now I know I'm talking to a very scientific crowd here, so let me get a little bit into the science. Water, you have different forms of water, solid, liquid, and gas, all right? When you have water vapor, that's the gas form. That's a higher energy form of water. When you force it up in an updraft and then you change that water vapor into cloud droplets and rain, you're changing the phase. You're going from a higher energy to a lower energy. And when you have that when that energy gets released, it's called latent heat. And so that adds more to the instability. So moisture condenses to form clouds. The heat is released. That adds even more instability. And so you get this thunderstorm going off like an atom bomb. All right, so that's ingredient number two is all the moisture. Number three is, you can have everything in place, but if you don't have something to actually push it, then nothing happens. Imagine a ball on top of a hill. All right, you push the ball any direction, it starts to roll away. It's an unstable situation. But if you don't push it, it'll just sit there on the top of that hill. So you need to have something to lift it, to get it going. And in the atmosphere, for us, usually, when we're talking severe weather, it'll often be a cold front. The cold front is just the front of cold air. The cold air is coming in, and as that front, the cold air plows into the warm air. It pushes it up, you get rising warm air, and that's your thunderstorm. And it can be very abrupt, and that's why the cold fronts are usually the fronts that are associated with severe weather. Now, you can get severe weather with a warm front, too. It's just a little harder to happen because the cold air being heavier, and then a warm front, the front of warm air trying to push that cold air. And so it just kind of glides up and over that more dense air. And so, yes, you can get severe weather, but one thing that can be a little more common with this type of front is flooding, because you can get repeated thunderstorms along that warm front as it slowly retreats. All right, and that's just, so if you don't have fronts, but you have mountains, that's another great lifting mechanism, because if you have warm, unstable air just running straight into the Catskills, that air has nowhere to go but up. And so that in itself, now this example that you see a picture of here, of course, is not the Catskills. But point being, the mountains themselves can be a source of lift to get these thunderstorms going. It's not just the air plowing into the mountains, but also think of the mountains on a sunny day, all right? And the sun is heating the slopes of the mountains, and so it's starting that updraft on the mountains, and then in between the mountains it's downdrafting. You get a little cycle going there, and so once you get that circulation, that can be enough to initiate thunderstorms. All right, and then finally, the top three are the real ingredients, but if you had the ingredients to make storms, now what type of storm will it be? That is based on wind shear. So let's really dial into the details on that. You see a very old, I don't know if this is microfiche or textbook, but the point being here is what is wind shear? Wind shear is if you have different speed and or direction with altitude. On the picture you see these little flags and barbs and things like that. The short barbs, the short barbs are 5 knots. The longer barbs are 10 knots. These little flags are pointing to the direction that the wind is coming from, and this is an altitude, okay? And when we say convection, we're talking thunderstorms. So meteorologists often say convection and thunderstorms ubiquitously. We kind of say that it's the same term either way. And so on the left example, you see, okay, there's a 15-knot wind from the south, and then you go up to 10,000 feet, and there's barely any wind at all, and then 30,000 feet, a little bit of a wind from the west. So kind of an unorganized, not much shear. If you go all the way to the right side, you have a southeast wind from 20 knots, and then at 10,000 feet, it's 50 knots. That's what the flag means from the southwest, and then it's like 90 knots at 30,000 feet. That's a lot of shear, not just different wind direction, but also different speeds. If you combine very unstable, high instability with a lot of wind shear, that's when you get your more major severe weather outbreaks. All right, so let's talk about that spectrum of organization for thunderstorms. Again, it's the updraft strength and instability. That's what determines how severe the storm will be. But is it only going to be a 5-minute deal, or is it going to be something that lasts hours? The shear is what determines that, how organized, how long-lasting, and the type of storm that you end up seeing. On the left, you see weak shear. On the right, you see strong shear. So let's talk about first the single cell. This, even though it looks like, oh, that's not as bad, well, true, but it still can be severe. It's just not as long-lasting. So for a single cell, you have an updraft. It just, boom, finally some trigger gets it going. Heat and instability, it just puffs up like an atom bomb. A lot of energy release. But here's the thing about it. Without shear, you get the updraft, and then it starts to rain, and then the rain comes down, and it cuts off the updraft. It actually, it basically just cuts itself off. This can be all less than an hour, easily less than an hour, the entire cycle. Straight up and down, and then that downdraft hits the ground, spreads out, cuts off the updraft, and that's it. So yes, you can get very strong winds as this water balloon basically drops out of the storm and very quickly creates strong winds and hail. But then it's done. The storm is done. So now let's get to where we have more shear. Here you get multi-cell clusters or a line. All right? And so what happens here is the source of the updraft is able to continue storms going, whereas the downdraft, it comes down, but it doesn't entirely cut off that updraft because the wind shear. It allows a longer lasting source of instability and updraft. And so the upper level winds is coming from either a different direction or a stronger wind. So it's dragging the first cell downstream, and then new cells are developing underneath where the wind is not as strong or from a different direction. You can get what's called back building, where storms keep firing and dragging over the same area, and that can cause flash flooding. And if you get an entire line of multi-cells, you get what's called a squall line. and that it can be a very, very, very long line. Here you see a radar example stretching from Michigan all the way down to Oklahoma, hundreds of miles long. And in this situation, we like to say the worst is first, because by the time the rain actually hits, usually the very strong winds push out right ahead of it. And so you get the blast of winds and heavy rain, and then things kind of sort of settle down. The worst is first in this example. When things get really bad, you get what's called a bow echo. Notice on the radar image there, you had what was a line, but then it spread it out into a bow. And that can be really, really bad. You can get 100-mile-per-hour winds or greater and stuff like that, which, again, it sounds like a freight train, right? So there's a tornado. People swear it was a tornado. In this case, no, it does not have to be a tornado. It sounds the same. It's rushing air 100 miles per hour, causing just as much damage as a tornado, but it's not a tornado. And actually, the damage in this situation can be more widespread, unlike a tornado, which is connecting the dots. So it could be worse. So where's the worst of it? Right at the front of that bow. That's where you have the strongest winds. Here's a more severe one, a bigger one, in Illinois, this example. And then you have this thing called a bookend vortex at the top. Believe it or not, you can get a tornado right in that. But the tornado itself, whereas the straight line winds of the bow, either way, it's about the same level of damage. It can be, like I said, the winds, the straight line winds can be actually more widespread than the tornado itself. All right, now let's talk about derechos, and we are overdue for one of these. This is very serious, where you can have a big squall line with hundreds of miles of damage, and it can be really, really quite bad. Probably the most infamous in our area is the Labor Day derecho of 1998, which killed 3 people, including 2 people at the New York State Fairgrounds, 10 injured as well. This came through really late at night, too, so it caught a lot of people off guard. I want to take you to our local page on this so I can show you this radar loop, what it looks like. And there you have it, all of a sudden bowing out as it went from Syracuse through Hamilton to Cooperstown. So that's what one of these also, when you have a derecho, the pace of these is screaming. I mean, it is flying along at freeway speed. In this situation, if you got a severe thunderstorm warning and you decided, oh, I want to go check this out, go out in your yard and see. If you wait till your eyes are giving you your warning of, oh, things are getting bad, it's too late. And you're setting yourself up as a sitting duck. These things come on very suddenly. There's all sorts of information, just so you know where to find this if you want to look into it more. If you go to weather.gov, you just click on our area, and then under climate and past weather, you scroll down, past weather events, and that's where you can find all sorts of nitty-gritty and all this stuff, all these different more infamous severe weather events, and also flooding, winter, et cetera, et cetera. So FYI, that's where you can find some of that stuff. Okay, now let's get into supercells. These are the ones that are more associated with tornadoes and stuff. This is where you have a lot of instability and a lot of shear. And the thing about this is, so you have the 100-mile-per-hour wind straight up in these updrafts with the overshooting top. And the thing that makes supercells special is with the winds going a different direction, the source of this fuel for the storm, that's what I'm trying to say, is heat and moisture. And if you got the heat and moisture coming from one way, but the storm being steered by winds going from a different direction, it'll always have, it'll keep that source of fuel. And so these things can go on for hours and hours. Also, how do you make a Play-Doh snake? You have, you in between your hands here, you go like that, different direction, different altitude, or on a table. That's how you get a Play-Doh snake. You get that rotation going, right? And then they get the strong updraft. It takes that rotation and it's able to make the whole storm rotate. And if everything goes just right, you get a tornado. So that's the situation we're talking about with a supercell here. Again, you get the overshooting top. You can actually see a radar image in the vertical here. with the overshooting top example here. With that very strong updraft, you're suspending not just big rain, but big hail sometimes. In this example, you see all this core of stuff reflecting in the 10 to 20,000 foot layer, but nothing underneath it yet because hasn't come down yet. And then that's how you get the large hail out of these supercells. You can also get, I'm sure some of you have seen this before, like after a severe storm blows through, and then all of a sudden you see all these little pouches on the underside of these storms. That can be a sign of extreme instability where you have, very strong updraft going up and around and to the top of the storm and then finally sagging at the end. And so, these mammatus clouds, it can be a sign of severe thunderstorms in the area. Here's a little closer to home. I know sometimes we're showing a lot of Oklahoma and Illinois examples, but here's an actual example right from here. On the radar, you see red and green right next to each other. Green towards the radar, red away from the radar on the right image. That's rotation. And then you see what's called a hook echo. This is a supercell here where you actually have the rotation of the storm peeling the storm into a curlicue. Hook echo doesn't mean you have a tornado, but it does mean that you have a lot of rotation, and it could lead to a tornado. Here is a louder example on radar of some very strong rotation. EF2 tornado in Pittston, PA. This is back in February of 2017. Yes, severe weather can happen any time of the year. And this was a pretty big example there. All right, and here's some of what the 2018 Wilkes-Barre tornado did. We got some drone footage here. This was not our footage, by the way. This was provided to us. And this hit a major shopping area, so it definitely made the news. I'm going to fast forward here a little bit. And you can see that this tornado left some places completely untouched, and other areas it cut right through warehouses and lifted U-Hauls and threw them around. So yeah, again, this is our area. We do get these. And they do happen sometimes in not expected times of year. Now this example is from mid-June of 2018. The other example I showed you was from February 25th, 2017. All right, moving on. Some signs that you may be perhaps getting a tornado is you get this thing called a wall cloud. What a wall cloud is remember in a supercell you have an updraft part of the storm and a downdraft part of the storm. And at that interface you can get moisture from the downdraft to get sucked right back into the updraft again. And because there's more moisture than the air surrounding it, it turns into clouds sooner on its way back up compared to the other air. And so you get this lowering of the cloud. And sometimes it's called a beaver tail, where you have you have this little thing pointing into where the rain is happening, but underneath the wall cloud itself, it's not raining, at least not yet. But there's a very, very strong updraft. You get a lot of rotation. This is not on the bottom image here. It's not a video, but you don't need a video to tell you that this is going in a circle. It looks like pottery being made. You get the spiral. So yeah, that's your wall cloud. Sometimes you may see what looks like an ominous shape in the thunderstorm cloud. Like say if there's lightning flashing and you see this thing that looks like wall cloud-ish and you're wondering, ooh, that's scary. The key is it rotating? You watch it as a spotter. Is it violently rotating? That's the key as to whether or not it's a real wall cloud. Sometimes you can see as the hook of the storm is forming and all that stuff and things are curling around, you get a brightening of that wall cloud. That can be, not always, but it can be a precursor to tornadic development. All right, now let's talk about scud clouds. SCUD stands for Scattered Cumulus Under Deck. It's not just those missiles in the Gulf War. It's called SCUD. It looks scary. It looks dark, but it is not severe. And the key here is it violently rotating. you see a picture of this and you're like, oh my gosh, there's the funnel. But now let's put this into motion. And yes, this video was sent in to the National Weather Service in Alabama because somebody thought, hey, this might be a tornado developing. But is it rotating? No. It just looks scary because when a cloud is dark, does that mean it has extra water in it? No, it just means light is not reaching it. So you might have a tall thunderstorm and sunlight trying to go through the storm and it doesn't succeed, and so you have dark clouds at the bottom. So that's all that means. And then the shape that it happens to be, there's moisture in the air, there's maybe a boundary going on there of some sort, but it's not rotating. Now, when there are clouds like this, we get all sorts of calls coming into the National Weather Service of people who are frightened. You, as a trained spotter, can tell us it's not real. When you call in as a trained spotter and identify yourself as a trained spotter, that's when our ears perk up and we're like, okay, this is a report to take more seriously. This is why we have trained spotters, because we get all sorts of noise whenever we get clouds like this. We need to know what's really going on. Okay. Again, you're science savvy and weather savvy. I don't need to go through some of this from Captain Obvious, tornado safety. But the key things are to get as low as you can and to put as many walls between you and outdoors as possible, because it's not the air blowing around that hurts you, it's the stuff blowing around in that air. So yeah, put as many walls between you and outside as possible. Somewhere in the middle is best, lowest is best because then all the debris is above you. Under something heavy is great. And cover yourself as best as you can. One thing I wanted to stress, do not storm chase on behalf of the National Weather Service. That's not what we're here for. That's not what a storm spotter is. You don't go chasing for the National Weather Service. We are not giving you any sort of permission to do that. And there are people who have unfortunately done that, who claimed, oh, I'm the National Weather Service storm spotter. I want to go through this barricade. No, that you do not have. We don't want you doing that. We don't want putting yourself in danger. And this is not at all a license to bend the rules on the law or anything like that. Okay, so now let's get into this. This is where the rubber meets the road. I mean, what do you report and how? Again, the key thing is it's listed fourth there, but number one, just right off the bat, say you are a trained spotter. Trained spotter from Tioga County. Great. Now we can really pay attention. When? Because sometimes it's like there's a tree down in my yard. Was it from yesterday's storm or the one that just is ongoing right now? That's important for us to know. When and where, not just Tioga County, but I am located 2 miles west of Owego, something like that. And what are you reporting? Is it not just a thunderstorm, but specifically, is there damage? How strong is the wind? How large is the hail? Okay, so specifics as far as what is worth reporting: any wind damage, downed wires, damaged structures, of course. If you have uprooted or downed trees, something more than just leaf bits and more than twigs, large branches down. We do want to know of any hail. We did talk earlier that large hail is considered quarter size or larger, right? Right. But we even want to know about small hail, because sometimes we are gauging how strong the storm is. Does it have hail or doesn't it? And we get a report from a trained spotter that says, hey, I'm having hail the size of dimes. Meanwhile, on radar, we can see that the storm's getting stronger. That may be enough to say, okay, we got to issue a severe thunderstorm warning for everyone downwind. And that's how you are serving your citizens, by doing that, by giving that advance notice. Also, as much as we can tell on radar, it's still difficult for us to tell how large the hail is. We can take a pretty good guess that there may be hail, but we don't know how big it is without the ground truth. Tornadoes and funnel clouds, of course, key is rotation, violent rotation. Is it rotating or not? Picture says 1,000 words, so yes, go ahead and send us the picture video if you got it. But again, don't chase on behalf of the Weather Service. Don't go looking for it. If you happen to have it, right where you're at, then go ahead and share it with us. And then of course flooding. And how do you tell, is it significant or not? Well, is it significant to you? Is this the parking lot that floods like basically every time it rains? Well, no, we don't want to know that. But is this the creek that you haven't seen out of the banks before and suddenly it's out of its banks? Yeah, we do want to know about that. Or water really rushing across a roadway posing a danger. We do want to know that. All right, wind damage again. I don't want to beleaguer this too much, but how big are the branches? Is it a tree that was just waiting for the final wind to knock it over because it was dying? That's worth knowing. Or is it a healthy tree with a snapped trunk? Can you estimate the wind speed? You can, because we don't want you standing out with a wind meter, anemometer, going, okay, it's 50 now it's 60, now it's, and then now you're hurt. We don't want you standing out in that. But here's how you can estimate the wind speed. If you have a weather station, great. Let us know how strong the wind was. But otherwise, larger branches are down. Some small trees are getting uprooted. Okay, that's roughly 60, 65 miles an hour. Large trees uprooted. Now you're talking more than 70 miles an hour. And then if you're talking not just uproots, but snaps of the entire trunk, that takes an even stronger wind. Because for an uproot, if you just get it started, then the weight of the tree will start pulling that over too, not just the wind. Whereas a trunk snap, that takes extreme wind, 80 mile per hour or greater. All right, so this is the part where we say, please don't share this number with everyone else. This is not a general public number. This is a train spotter number, and when it rings, we know it's a train spotter. 1-800-759-2992. So that's especially like if it's urgent, like you're seeing a tornado funnel coming down to the ground and you really want to give us the play-by-play right now, you call that number and you're going to get a forecast. You're going to get a human being here in the operations. But if you have something that's more like a picture says 1,000 words and you want to send us a picture, that would be bgm.stormreport@noaa.gov for email. And then some other examples, social media coming up. Again, however you make a report, train spotter is number one. I am a train spotter for Madison County or wherever county you're in. Who, what, where, and when. You saw 1-inch hail. I'm 2 miles to the west of Cazenovia or south or whatever, and what time you're seeing it or if it's ongoing right now. Here are some other options for ways you can submit reports. INWS.ncep.noaa.gov/report. So that's one option there. If you Google any of these, most of them will come up. There's also this thing, if you're really interested in being a weather geek, it's called MPing. And so if you Google MPing, that's MPING, and weather service, you'll end up finding this. What's cool about this is, sometimes in winter it can be hard to tell, is it rain, is it snow, is it freezing rain, is it sleet, what the heck is it that radar is showing? And this will allow not just the weather service, but anybody who follows this to know what's going on, what types of winter weather, what have you. And you do have the option to select not just type of weather, not just precipitation type, but if there's significant things going on. Now here, of course, in the advent of social media in the past decade, this has become very valuable. Of course, we all like to trash social media as being like a negative, right? Oh, Facebook has gotten so horrible and blah, blah, blah. Well, this is a way you can make it positive, all right? A lot of people are on Facebook and Twitter. We all are, right? Most of us are. And the beauty of this is not only you reporting to the National Weather Service, you're reporting to anybody who happens to follow the National Weather Service on Facebook and Twitter. And they're getting it all just like when we're getting it. And so it really amplifies your report and makes people aware of what's coming. And a picture says 1,000 words, and it's very shareable on Facebook and on Twitter. And I encourage you to follow us on Facebook and Twitter. We're putting out information there all the time. All right, to summarize, how do you make your report? The way that works for you. The way that you'll actually make the report is the one that we're interested in. Again, if it's really urgent, the number is the best to go. But, that is, any report can come in through the number 1-800-759-2992. There's the email, bgm.stormreport@noaa.gov. There's the online options there, Facebook and Twitter. Just Google it, you'll find it. And then I want to give a plug for ham radio, because when everything goes down, we're talking like major ice storms, like in the, like, when was that, late 90s, where you had 1 to 2 inches of ice in northern New York and in Quebec, and it brought down the biggest power lines. Everything went down. No cell, no anything. Everything gone. Oh, wait, there's ham radio. That is the last line of communication. That is what still works when everything else goes to crap. I'm KE7GGC myself. I know Drew is also a ham radio operator. We love our ham radio operators, and they're a big part of SKYWARN. Okay, and so now that's a little bit of, you know, what makes all the severe, what makes storms severe, how do the thunderstorms come together, how are they organized, how do you make your report. Now you're wondering, okay, when am I going to make that report? Can I have a way of knowing that severe weather is going to be possible in the next few days? I'm going to turn this back to Brian. He's going to tell us about the ways that you can know what's coming and self-brief.
All right, let's finish the game of musical chairs here.
Yep.
So like Mark said, I'm going to wrap up this presentation. So there's not too much left. I'm just going to talk about how we get the word out and just kind of wrap up the rest of this. So the National Weather Service has a 3-tiered approach in terms of all the products that we issue. When you're further away from the event, we have outlooks. And then when you're near the event, or the event is just about to happen, you have warnings. And I'll explain on the next slide what the difference is between a watch and a warning. But basically, there's a 3-tiered approach, and that is National Weather Service wide. A local forecast office has this 3-tiered approach. National centers have this 3-tiered approach. Specifically, the Storm Prediction Center in Norman, Oklahoma. You'll see a outlook of expected severe weather for the next few days. They also, in collaboration with us, the field office, they are the ones that actually issue the watches for severe weather events. We're the ones that issue the warnings. But there's a lot of communication between us and the Storm Prediction Center in advance of events. So one of the outlooks that we do issue here at the local office here at the National Weather Service is something called the Hazardous Weather Outlook. And this is a text product, and more recently there's actually a graphical product on our website. I can actually show you that in a minute here. But basically, sometimes it's several days in advance, maybe in a week in advance, especially in the winter. If we're expecting if we're watching a potential for a major snowstorm or something like that, 5-6 days out, we may have in our text hazardous weather outlook a little blurb in there that says we are keeping an eye on a potential for a significant winter storm to impact the area. Stay tuned for more details as we get closer. Same thing with severe weather. If we're expecting some severe weather several days out, we will do that as well. So go into our website real quick. So I don't need to give us feedback. So we have, if you go down to the bottom here, there is this little tab here. It says Graphical Hazards. So if you click this, and we actually just recently moved it to a different page, so just click the link. Eventually this will be replaced by the actual page. This is just so people can update their bookmarks. So here it is. Again, this is the graphical version. There's also a text version that appears on our main page. So basically, we have all these different hazards of what we're expecting. Now, for example, this is actually a very good example. So day 1, that's today. Today's Friday. Day 2 will be Saturday. On Sunday, there is a marginal risk for possible severe thunderstorms. Right now, it looks like more hit or miss, but we'll see as we get closer. But anyway, on Sunday, it is highlighted in this yellow category. And we have the legend at the bottom here. It says isolated to scattered severe thunderstorms possible. So this is a little bit more color-coded. So you see we're not expecting any severe any times in the next couple of days. And we have all these different categories. In the winter, there will be additional categories that replaces these severe categories. So we'll have snow, ice, and frost. Well, frost freeze is still on there right now. just because we're still in the transitional season where we can see some colder mornings. And going back to our presentation here. So as I mentioned, the Storm Prediction Center, which is based in Norman, Oklahoma, they are part of the National Weather Service. They are another one of our national centers. They issue outlooks every day with different categories. Remember I said on Sunday we are in a marginal risk for severe thunderstorms. Well, that risk was given by the Storm Prediction Center, and that is a 1 out of 5 on the scale here. That just isolated severe thunderstorms possible. And I'll show you an example here. Real quick, go to SPC's website. Oops, spc.noaa.gov. You just Google Storm Prediction Center, you'll see this. So this is their main page here. And on the side here, you'll have all their watches and their outlooks. So if you go to, let's see, day 1 convective outlook. So this is the current day 1 outlook. Also underneath it, for those who are interested in more of the meteorology behind it, there's a discussion, which is a little bit scientific, but that's a discussion of what the forecasters there are seeing. So you can see where in the country there is possible severe weather. So we have marginal risk up down by Louisiana and Texas, marginal risk up here, slight risk. This is where I guess where they're expecting the highest risk, which is still 2 out of 5 out here. Remember I said our day 3 outlook. We're actually so day 2 it's tomorrow. We can get some general pop-up storms. But day 3 here is a pretty large swath of a marginal risk. Does not mean that it's going to be a widespread severe weather. In fact, it's quite the opposite. Again, it's more isolated pop-up, stronger storms. This is where day 3 they're expecting it. As we get closer, they'll fine-tune it a little bit more. You won't see such a large swath of an area. Marginal risk. You might see a particular area that may have a slightly larger risk be upgraded to a larger risk. So that is what their website looks like. Oops. Let's go back to full screen here. Okay. So again, what is the difference between a watch and a warning? Well, a warning, and you can kind of see from this graphic here, it means take cover now. It means it is on your doorstep or it is already occurring, especially with severe weather. Meanwhile, a watch, conditions are favorable for it to occur, but it is not occurring yet, or it may not occur at all, depending on exactly where you're located. But it just means the conditions are favorable. For winter weather, it's a little bit different. We call them longer fused warnings, where a winter storm warning or a blizzard warning may be issued a day or 2 in advance. But for winter weather, the only short fused warning there really is a snow squall warning. That's kind of like it's very similar to severe thunderstorm, really, just in a winter form. But for severe weather, you're dealing with shorter fused warnings. So many different ways to receive our warnings. The primary way, and really the best way, is through NOAA Weather Radio. These are easily found in hardware stores. You can order them online. And basically on a regular day, our day-to-day forecast is overlaid on there. But during severe weather, there will be an interrupt tone, an alarm that goes off, and it'll read out the warning that is going on. And that is sent immediately. As soon as we press the button to send the warning, it goes directly to weather radio. So that is the primary way. But there's also other ways. WEA, which is the wireless emergency alert system. That is when the warning buzzes off on your cell phone. Now, not all warnings go to your cell phone. Just the higher-end warnings, the tornado warnings, higher-end flash flood warnings will go to your cell phone. And I actually have a slide on this a little bit later. But starting in July, as long as there are no other delays, there have already been a few delays. In July, higher-end severe thunderstorm warnings will be going to your phones as well. As of now, severe thunderstorm warnings do not go to your phone unless if you're subscribed to a second or third-party app or something like that that's not affiliated with us. There's also NWS for emergency managers. So, a little overview of our website, and what I'll actually do, instead of showing these slides, I might as well show our live website. And Mark showed this a little bit before, but go to weather.gov. And here you'll see all the different alerts that are going on across the country. So depending on where you're located, again, I know there may be some people in the audience here who may not be from our forecast area. They may be a different part of the country. So just click wherever you're located, and you'll get your local forecast area's website. So for our area, you'll click over here. We do have a air quality alert in effect for a good portion of central New York. That's actually not issued by us. We're the one, we do send it out, but that's actually not, that's from the environmental agency. But anyway, you're on our website, and what you can do here is you can look for, you can either click on the map for your forecast, or you can type in your zip code. So let's say we are near Ithaca, for example. You can click on Ithaca, and this applies to any part of the country. There might be slight differences depending on which region of the country, the way the website looks, but for the most part, it should be very similar. You click on the map, and you get your particular location, the forecast. And here you have the forecast for the next several days, and a little bit more of details down here. If you want even more detail, if you scroll down, and on the right side of your screen, there's an hourly weather forecast link here. If you click on this, you'll get an hourly breakdown of temperatures, dew points, wind speeds and directions, potential for precipitation, what we call POPs. If there's any thunder in the winter weather, in the winter season, you'll see if there's any snow in the forecast and how much during that time frame. And you can kind of scroll to a different time. It goes out a few days. So let's say, I don't know, let's go to Sunday, for example. We'll go to Sunday, 12 p.m. Sunday. So this is it. This is our forecast for Ithaca for starting 12 p.m. Sunday. So you can see the temperatures and the precip chances and all that. Let's go back to our website here. Okay. And again, you'll see all the different alerts that we have out. So this is a pretty quiet day. You just have the air quality alert. Going back to the presentation here, I'll kind of skip through these slides because I basically just went over it. So a busier day may look like this. So a busier day, if there's a severe thunderstorm watch or a flash flood watch in effect, may look like this. A lot of different colors on that map that you see on our website. I was talking about the wireless emergency alerts before, so I'm just going to skip this slide. This is just a graphic. There's a link at the bottom here. If you just Google WEA wireless emergency alert, you can get this link for the National Weather Service. Now, we also have a mobile version of the website. We do not have an app, but this behaves a lot like an app. So basically, you go to mobile.weather.gov, and you'll get a screen that kind of looks like this. And depending on your device, if you have an Android or an iPhone or another device, you should be able to add that to your home screen. And basically, it behaves just like an app. You click on it, and you basically get a forecast that way in a more of a mobile-friendly format. I touched upon this before with the wireless emergency alerts. There is now going to be a change. This was supposed to actually go into effect in April. There was a little bit of a delay, so it's been pushed back to July 15th. We're hopeful that it stays at July 15th, but if there's any delays, it may be pushed back, maybe to the fall. But for now, it looks like July 15th, this is when this is going to start. So impact-based warnings have been in existence for many years now, at least 10 years, probably closer to 15 years. And what these are, it says, and I'll actually show you. Okay, I don't have an example here. But anyway, it'll explain what, where, when, basically a little bit more of an easier format to read. At the bottom of the warning, at the bottom of every warning, there is a machine-readable, what we call tags. And for the past several years, we were able to have enhanced tags for flash floods and tornadoes. But new for this year, we can actually do extra tags for severe thunderstorms at the bottom of the warning. And I'll show you an example in the next slide. So a base warning, which is no tag at the bottom, is your default severe thunderstorm warning. They're still dangerous, but it's not going to go off on your cell phones. Where on this column here, where it says WEA, it says no, it will not go off on your cell phones. And that's for wind speeds of 58 miles per hour or greater, or 1-inch diameters, hail or larger. considerable tag will also not go off on your cell phones. Again, we don't want to be annoying you all with every single warning. Yes, every warning is important, but we also want to emphasize the really, really, really dangerous storms. So the considerable tag at 70 miles per hour or greater, or golf ball size hail or larger, will also not go off on your cell phone. Keep in mind, the way it's currently formatted, no severe thunderstorm warnings go off on your cell phone. Now the change is when we have a destructive tag that is 80 miles per hour winds or greater, or baseball-sized hail or larger. Those will go off on your cell phone starting in July or later if it's delayed again. So here's a few examples. Again, these are tags all the way at the bottom of the warning. So example of a base tag where we have, in this case, we have 1-inch diameter hail and 60 mile per hour winds. Well, looking at this chart here, that falls under the base category, and it will not go off on your cell phone. A considerable tag will also not go off on your cell phone, but it kind of gives you a few more details. Okay, max wind gust 70 miles per hour. In this case, the hail size is still 1 inch, but a considerable tag may also say 1.75 or golf ball sized hail. At the bottom here, this is what will go off on your cell phone whenever it's at the bottom of the warning, where it says destructive. In this case, in the left, we have an example of a hail destructive severe thunderstorm warning. And in this case here, we have a wind destructive one. So hail size 3-inch diameter, that is very large hail. And here we have 90 mile per hour winds. 90 mile per hour winds will cause quite a bit of widespread damage. So again, those will go off on your cell phones starting in July. So wrapping it up here, and then we'll take questions at the very end here. So wrapping it up, why do we have train spotters, and why do we need you? Well, again, we have all this technology at our disposal. We have radar, we have satellite, we have the general public also that call in reports. But the train spotter is basically a confirmation to us that, okay, they know the fundamentals of what is a severe thunderstorm, what is severe. And while we do appreciate any report, whether it's from the public or whoever, it provides extra credibility if it's a trained spotter. And also, it'll help us real time during an event. Let's say if we have a warning out for Tioga County, New York, and it's looking like it's weakening on radar, but we're not really sure. It looked like it might be borderline severe, not severe. But then we get a report that it's dropping quarter-sized hail. Well, that's severe criteria. That may be enough for us to issue a warning further downstream from Broome County. So it basically supplements what we already see on radar. So again, the radar can only tell us so much. Here's again our toll-free number, 1-800-759-2992. Again, do not give this out to your friends who are not trained spotters. This is only for trained spotters. Let's see here. And I believe this is the last slide. It looks like Mark was able to get back on the other computer, so perfect time for questions after this slide. So there's no need to call us when there's just lightning and thunder. Of course it's noteworthy, but we don't need to know when there's lightning and thunder, or it's really windy. Well, okay, but we can, and as Mark touched upon earlier, even if you're seeing hail that is less than 1-inch diameter in size, or if we have a warning out that is saying that it's going to cause a lot of wind damage, and it's really just nothing more than a breeze for your particular area, and it went right over you, feel free to call us, even when the event is not happening. That will be probably enough for us to consider canceling the warning early or not issuing a warning downstream. So definitely anything, any wind speeds or any sized hail, feel free to give us a call. And with that is the end of our presentation. We'll take questions in a minute. I showed you our main National Weather Service website. That is weather.gov. You can either click on our particular area and reach our particular office's website, or if you want to go directly to our office's website, that's weather.gov/BGM. Feel free to send us reports through email as well. bgm.stormreport@noaa.gov. If you have any questions, feel free to do that as well. And you can also email us. All of our emails are pretty easy to figure out. It's firstname.lastname@noaa.gov. So you can email either one of us with any questions you may have if something comes up later on. So with that, I think you're going to feed us questions. Is that correct?
Sure. Yeah. We'll wait for a few questions to show up. I do want to give some shout outs to, we've had people here from Sayre, from East Smithville, Pennsylvania, up in Windsor. A number of hams have checked in, and so shout out to the hams, Jim, KF2WJ, and WX2USA, and KC2MLB. Got to push the ham stuff there for a little bit. The ham station at the weather station in Binghamton, I think, is WX2BGM, which
Yes.
would make sense. And I did want to sort of say thanks, especially to the people out sort of west of Binghamton. I would think where most of our weather tends to come from the west. Getting information on what's going on in the west is really sort of helpful and sort of helps inform you of what we might be seeing here in Binghamton. Is that a sort of a relatively correct assumption?
Oh yeah, that's generally true. Now, I mean, we do coordinate regularly with the weather services up like in Buffalo or down in State College. But yeah, as far as really being in tune with what's about to hit across the rest of the area, if you happen to be in Corning or Penn Yan, wow, do we love your reports, especially. It's very golden because you are providing a service, everyone downwind, including the Binghamton and Elmira areas and Ithaca and all that, right on down. So, but yeah, any reports, of course, are great. But yeah, those ones that are upwind, that tend to be upwind,
yeah,
especially valuable.
Very good, very good. I did notice a couple of things on some of the slides there. Again, I noticed that a lot of the tornado tracks tended to be, at least from what I could tell, sort of from west to east. Although there was definitely one or two that really went up almost directly north. The one up near Albany there, and that seemed to have a particularly long trail to that. So you're right. I mean, the bottom line is, you don't know for sure where things are going to be. Yeah, there you go. One thing also that I don't know if you can comment about, how the jet stream affects the direction of these storms. And I mentioned the jet stream because we at Kopernik have done a number of weather balloon camps up here where we have sent balloons, and we've made sure the FAA knows about it. But what I found very interesting is the balloon will be, as it's rising in altitude, it'd be following the jet stream and sometimes it'll be going 50, 60, 70 miles an hour, and then up around 60,000 feet, all of a sudden it just changes direction and it just sort of floats another way. So I'm wondering if maybe you could comment on how the jet stream would impact against severe weather.
Did you want to take that, Mark, or do you want me to answer that?
Sure, I can grab that.
Okay.
Okay, so the jet stream basically guides whole storm systems across the country. Generally west to east, but it does change direction quite a bit. We also pay attention to sometimes the jet stream can really influence how much moisture, like if it's able to bring up moisture from tropical regions. I'm talking like Baja California or any of that.
Mm-hmm.
It can guide that. Depending on the orientation of the jet stream, if we're in one position, it can initiate lift in the atmosphere, like basically encourage storms to develop more, whereas other times discourage. Now, it doesn't necessarily decide whether or not the storm's going to develop, but it can provide help or not help. The higher up you go, also the jet stream, we're talking many, many miles up in the atmosphere. and it can steer the storms, even individual storms. If the storms are tall enough, it can sort of drag storms along one direction versus where, again, like it's like a wind shear thing. You can have the source of fuel for the storm coming from a different direction. So, yeah, so
All right.
there's all that. Brian, you want to add anything to that?
I mean, you've covered it pretty well. I mean, the jet stream is kind of where a lot of storms track along. It's definitely it's a big driver for a lot of the weather, and it provides. And as you mentioned, I mean, if you launch a weather balloon right into the jet stream, it's going pretty far.
Yeah.
And that may also introduce you have some wind shear. So
jet streams tend to be a little stronger too in the winter season.
Yes.
You can get way over 100 miles per hour with jet streams, and Mount Washington can kind of sample that sometimes.
Yeah, I've heard they. I used to live in New England, and you would hear about some of the crazy weather that they would have there up on Mount Washington. We do have a couple of questions that came through here. Oliver asks, why do storms come up quicker over water, and are these more powerful?
Well, why do they come up quicker? Was the question?
That's why do storms come up quicker over water? I guess I'm
okay. Well, in terms of like wind speeds, because I mean, with over water, you're dealing with less friction. So winds may be a lot higher over the water. In terms of development of storms, it depends on the air mass in place, but actually a lot of times the ocean or a body of water may actually decrease the strength of the storms or kind of weaken storms, only because it's more of a stable layer. Mark touched upon this earlier with instability. With the ground heating up in the afternoon, water takes a lot longer to heat up, so it's not as unstable. Growing up on Long Island, I mean, there's water surrounded everywhere, and there was always a joke going around that all storms seem to die as they reach Long Island, and that's because it's reaching a more stable air mass. Sometimes a cooler air mass as well. I don't know if Mark wanted to add anything about that.
Sure. What water can do, because the air sitting over the water is cooler than the air sitting over the land, it can form a boundary upon which to make storms develop. And so maybe not right over water, but the boundary, or the lake breeze, in the case of Lake Ontario, or the ocean breeze, that boundary can act as a miniature cold front to initiate storms on its own. You also have, the Finger Lakes. So the Finger Lakes themselves don't make storms, but the terrain around the Finger Lakes, you can actually get updrafts from one side of, say, Seneca Lake and another side of Cayuga Lake meeting in the middle and generating storms just like that. That can often happen, like, say, around Watkins Glen, up at the Speedway, at the racetrack there. They can have stuff just kind of burp up in the middle of nowhere, just out of nowhere is what I'm saying. Very suddenly.
Interesting. Okay. A couple more questions. Cindy asks, how soon do you get severe weather reports from CoCoRaHS? Maybe you could explain that. And should should we do a spotter report as well as a report on CoCoRaHS?
Well, CoCoRaHS. So generally we're talking about rain gauges. Those it's available on the website and also gets directly sent to us. There is a little bit of a lag. So the best way in terms of reaching us immediately is contacting us directly. What was the other second part of the question?
It was should we do a spotter report as well as a report on CoCoRaHS?
Oh, yeah, feel free to. It's definitely best to contact us directly. So sometimes while we do see the CoCoRaHS data, sometimes there's a little bit of a lag by the time we get to see it. So if there's something noteworthy, especially with heavy rainfall, if you're dealing with heavy rainfall, let's say, I don't know, 3 inches of rain fell in 1 hour. Okay, that's definitely worth calling in about that.
All right, very good. We got another question. Are we measuring increased variability in weather elements in the area that you would attribute to climate change?
Yeah. So to be honest about that, we're so hyper focused on the next, like at the Weather Service office locally, we're focused basically on the next 7 days, usually. So we really dial in on that. But you know, there is something to be said about like when you have, let's see, how do I put this? This is getting really sciencey here, but all right.
We're a sciencey place.
One of the things that drives the climate and the weather is you have, you know, big differences between the poles and the equator as far as the amount of heating and all that, and that difference between polar air and equatorial tropical air being, you know, so different, and then the weather systems keying off of that difference. One of the things that's being observed with climate change is while there's changes, all, you know, there's general changes that are occurring at all latitudes, and in some places even cooler than warmer and all that, but the balance is warmer. The biggest differences that are occurring are at the Arctic and polar latitudes, and so when you have more, you know, I'm doing the best I can to describe this, but by decreasing the difference, that's what I'm trying to say. If you have a lot more warming occurring at the Arctic versus the tropical regions, you're decreasing that difference. And by decreasing that difference, you are, the jet stream, you're potentially making it not as strong, the steering of that. And so the jet stream can get a little more stuck in positions at times. And I will be the first to say that I am not a climate expert myself, but these are some of the things that are being observed, is that the jet stream sometimes can get pretty stuck in position. And so that can lead to things like a wet pattern being stuck over one area and leading to flooding, or a dry pattern being stuck in another area for a longer period of time, leading to more drought or more extreme drought, things like that. So now when you go to the individual thunderstorm level and stuff, or tornadoes, there's not really any way to key that to climate change, but big overall patterns, that's a different story. You also see, I don't know, we you know, Brian does a lot of hiking. I do a lot of hiking too, and you see things happening like in the Catskills, the Poconos, especially the Adirondacks. Some of the elevation changes that are occurring with the trees and all that stuff. But yeah, again, we're a National Weather Service local office. We're focused mostly on the weather in the next 7 days, and we don't dive in as deep into climatology.
All right, good.
Now the ones who, sorry, no, I was going to say the ones who, remember I was saying we have national centers as well. There is the Climate Prediction Center, and over Mark's shoulder is actually a little graphic on that banner. So the Climate Prediction Center is part of the National Weather Service that does specify and a little bit more of the climate outlooks and things like that. But yeah, but as Mark said, we primarily focus on the day-to-day and the smaller scale features in our particular area, so for New York and Pennsylvania.
All right. Cindy asks, what is a dry line, and do we get them here with strong cold fronts?
A dry line, so it's where you have quite a bit of, it's basically an invisible boundary where you have kind of converging air, a lot of rising air, and as it's kind of self-explaining dry line, there's really not much there initially, and a lot of times that is enough lift at that boundary, different changes in wind direction, to cause thunderstorm development. So I don't know if Mark, if you wanted to go into a little bit more detail on that, but that's basically it's basically a boundary. We were talking about different boundaries can cause areas of lift.
So one thing that is weird is, you know, sometimes you hear about the atmosphere holding moisture, and so it makes it seem, you would think, oh, that means heavier, right? Like a sponge? No. Water vapor, if you take a chunk of water vapor and then a chunk of regular air and put them next to each other, which one's lighter? It's the water vapor that's lighter. And so if you have a humid air mass with water vapor in it, it's actually on average lighter, not as dense as just plain air. The water vapor is lighter, less dense. And so when you have a dry line, you have a dry air mass moving into a humid air mass. The temperature may not be any different. It may not be a cold front, but it is a dry front. It is heavier air moving into lighter air, and so it can behave just like a cold front. Dry lines are, as far as generating severe weather, that's a little more associated with, say, out in the Central Plains and the Southern Plains. You have a dry desert air mass type, like coming from New Mexico, Colorado, whatever, and shoving into humid air mass sitting over Texas, Oklahoma, Kansas. That dry line can initiate severe weather. Now, what we do have is, this is getting really, really sciencey, okay? We call them EMLs, elevated mixed layer. What that is when you take that desert air mass and all that, and it rides up and over via the jet stream, rides up and over humid air at the ground level. That, again, is an unstable situation. It is as if you put cold air above warm air, makes it unstable. So we do watch for that. We watch for really dry air masses coming from way out west and riding up and over our humid air mass. And so that's not a dry line, I know, but it does also lead to severe weather sometimes.
All right. Well, great. Well, that seems to be the question. We have for questions right now. I want to thank you both for your time here with us today, but also just your service to us, keeping us safe. I know, it's especially lately. I've been really cognizant of the weather and what it can do to us. And as I said, this past winter I had to scrape 40 inches of snow off the domes up here. So being prepared for that is really helpful. And it actually, it was happening right before our Jupiter-Saturn conjunction, so I had to scrape the domes to prepare the scopes for that. And but also, actually, if you could stop sharing, I was going to just show. We actually have a weather station up here at Kopernik. So I don't know if Brian. Yeah, there we go. Yeah, here we go. Let's see if I can. I'll bring up our.
Did I stop sharing, or I don't know if that worked?
No. Okay, here we go. Yes, if you go to Kopernik's website and under visitor info, you come down to weather, and we do have a weather station that is on the CWAP network. We're actually Weather Underground in South Vestal, but so you can actually find out exactly what's going on at Kopernik, right now. So temperature-wise, when it tells us it's currently 77 degrees, and all that other good stuff. The other thing actually we have up here that I like looking at is we actually have a weather satellite image. We've got a small little Raspberry Pi with a software-defined receiver on it that we can pick up the NOAA 15, 16, 15, 18, and 19 images, and so we can actually see. Well, this one's got a little interference, but this is the MCIR precip, and you can sort of see what's going on. So, like right now, you can, as of 23:48 GMT, that's what it looked like in infrared. So, if you feel like checking that out, you can go to our website and do that as well. So,
hey, Joe, mind if I share my screen real quick?
Oh, please.
All right, I got a couple things to show you real quick here. First of all, that's the beach. Okay, that's.
Yeah,
I did find your weather site, which is pretty cool to know about. So you go to Kopernik.org, and it seems to be under visitor info, weather info, and there it is. Awesome.
Yeah.
Highs and lows and current conditions. It's
Okay.
great to know about. Thanks.
I guess I wasn't sharing. I apologize. Yeah, thanks for
That's all right.
picking that
The
up.
other thing I wanted to show is that somebody mentioned cocoa Raz. Perhaps some of you out there wondering what's cocoa Raz? Are you cuckoo for cocoa Raz or whatever? Cocoa Raz stands for Community Collaborative Rain, Hail, and Snow Network. It is not Weather Service. We did not organize it. However, we benefit greatly from it, and so we are happy to promote it. It started basically because, like the network of how much rain and snow has fallen in a given area can be pretty sparse sometimes. And there was a major flood in the Front Range of Colorado. Was it Fort Collins flood maybe? I can't remember for sure, Brian. But basically in town they got hardly anything, but immediately west they had like a foot of rain or something crazy like that. And there was epic flooding and there was fatalities. And out of that event, this was organized by I forget who organized it initially, but it's great because here what you see here, for example, I'm just clicking on here, you can see how much rain was reported, and a very tight network of reports, 24-hour amounts here. You see parts of Wisconsin had over 2 inches, 3 inches of rain. And while this is great, it's great information to have, there are ways to actually make storm reports this way as well. Whereas this is every, once a day, 7 a.m. If you do a CocoRa's report, I'm trying to remember how to do that myself. It's because I'm not logged in. But if you do sign up for CocoRa's, you can get training on here too. And if you make your report via CocoRa's, it will instantly let us know. If there's a large hail report, for example, it flashes right on our screen and we can't miss it. And so it is another way to make your storm report is via CocoRa's.
Great. Excellent. All right. Well, thank you so much. Really appreciate your time. Got some nice positive comments. 5 stars. So it's all good. Anyway, and again, I thank you both for again realize you guys are, not officially on today. So thanks for joining us this evening, and just also for what it's worth for those like looking up in the sky. So tonight at 10:20, if you're here in the southern tier, if the skies are still clear, the ISS will be flying by. So it'll come out of the northwest about 10:20, get to a maximum elevation of about 16 degrees. So you're going to need a relatively good northern horizon, but you should be able to see the ISS come by and stay up through its entire path. So if you like to watch those satellites, there's a good one coming up in about an hour and 20 minutes.
That's good to know because we're, being at the airport, we have a pretty good view.
Yeah, absolutely. So, well, thanks again. I really do appreciate your time. Next week, we've got another program. It's going to be a tour of the solar system. This is by Zoe Lerner-Pontario, who works up at Cornell in the astronomy department. We'll take another probably a week break in the beginning of June, and then on June 11th, I believe that Friday, Phil Cooper, one of our favorite presenters, is going to be doing a talk on the Skylab mission, and he always has some great background information that people normally don't get. So anyway, so thank you both. Again, if you liked what you saw and you want to be part of this on an ongoing basis, click the subscribe button down below if you're not already subscribed, and if you're in a position to do so, to help us, with the donation, that's always helpful. Mark, Brian, thank you again, and have a good weekend.
You too. Thank you so much for having us.
Our pleasure. Thanks.